Welcome back to B Spice. In this session, again, we'll continue with instrumentation, question and answer. Here we'll focus on part 7b. The focus is on the TCP IP model again. Okay. See, as you look at this picture, friends, you see here, this is the OSI model, Open System Interconnect model, right? So you can see here the physical data link network transport session, presentation, and application. So 1, 2, 3, 4, 5, 6, 7, right? 7 layers. Now you see how the TCP model is defined. Network access, internet, transport, and application. Only 4 layers. So that is what we are going to discuss. All these actually, what is IPv4, V6, UDP. In fact, we already covered DNS. All these we are going to talk. Of course, there are many more to come in the subsequent sessions. So hope you have watched the part 7a. If you have not watched, I suggest to watch because that is very important and very interesting also. Okay, friends. So let's move on. Okay, I'll just start with OSI model. Okay, see what is OSI? Open System Interconnection Model is a conceptual framework that standardizes the functions for telecommunication protocols into 7 abstraction layers. That's it, right, friends? We have seen in the intro part, right? There are 7 abstraction layers. So I repeat again, OSI is a model, is a conceptual, framework that standardizes a function for telecommunication protocols. That's it. Okay. So TCP IP model is most simplified version. You can look at it here, right? Consists of only 4 layers. Network, sorry, maybe I'll go with this top: application, transport, internet, and network. That's it. So this is the simple explanation, okay, for a better visualization. Now I'll go into the detail actually. Okay, now I'll focus on ICMP. Friends, these are all very important actually. These are all very important, not only for the interview. When you go for a competitive exams, all these will come into picture. Okay, so yeah, I suggest to watch. I suggest to watch. In fact, start from the beginning. I mean, the first, part 7a. Okay. So ICMP is nothing but Internet Control a Message Protocol. Is again a network layer protocol in TCP IP suite used mainly for error handling and diagnostics. That's it. So Internet Control Message Protocol is a network layer protocol in the TCP IP used mainly for error handling and diagnostics. Okay. See what it does. It enables hosts and routers to communicate network related issues such as, sometimes unreachable destination or sometimes the time exceeded for a packet, all these cases, right, friends? Right. So it enables hosts and routers to communicate network related issues. Right. Then tools like, we use the ping, right? Yes, ping, tracer route. This utilize ICMP to test network connectivity and path destination. The ping is a very, very appropriate example. We do that, right? We ping, right? Yes. So basically it utilizes ICMP. Okay, that's it. So that's about the ICMP. Then now one more concept, NAT. What is NAT? NAT is nothing but a network address translation. So basically it's a technique used in TCP IP to map private IP addresses within a local network to a single public IP address. I hope you can able to visualize. So it's basically a technique to map private IP addresses within a local network to a single public IP address. Right, friends? So there are various IP addresses. Okay. So it mapping the various IP addresses within the local network to a single public IP address. That's it. So this allows multiple devices on a local network to access the internet using the same public IP address. That's a advantage. This allows multiple devices on a local network to access the internet using the same public address. So this actually enhances the security by keeping internal IP addresses hidden from external networks. So that is the advantage. It also helps to conserve public IP address space by allowing many devices to share a single public address. That's a beauty, right? So one part, it enhances the security. Other part, it hidden the IP address, keeping the internal IP address hidden from external network. So thereby to conserve the public IP address. Okay, that's a NAT, network address translation. Okay, now IPv4, IPv6, we have seen yesterday in the part 7a, right? Okay, little bit more of a description or maybe, differences. So IPv4, IPv6 are two versions of the internet protocol used in TCP/IP. This is all we know, right? Okay. IPv2 uses a 32-bit address format, leading to a theoretical maximum of around 4.3 billion unique addresses. Okay. So the format and all we have seen, right? 192, all these, right? Okay. So IP6, D6, recognizing the exhaustion of IPv4 addresses, uses a 128-bit address format. Okay. So basically this IPv6, recognizing the exhaustion of IPv addresses, uses the, once it is done, exhausted, then this will be, uses a 128-bit address, which also we have seen actually. It's like alphanumeric character. If you have not watched, you can watch the part 7a and get to know. Then this gentleman IPv6 introduces improvements in routing, network configuration, and security. Okay, so these are some of the basic differences. And another important thing, ARP. What is ARP? ARP is nothing but the address resolution protocol. Basically, it's a protocol within the TCP/IP suite that maps an IP address to a physical address on a local network. That is a point. It maps an IP address to a physical in the sense MAC address on a local network. Okay. When a device wants to communicate with other devices within the same local network, it uses ARP. You got it, friends? Yes, that's it. To discover the corresponding MAC address. So ARP request is broadcasted on the local network, and the device with the matching IP address responds with its MAC address. That's it. That is how the whole functionality happens. This is all actually, very simple, right? So nothing to explain further here, right, friends? This is ARP. Okay. Then, gateway, right? So we talk, what is the role of gateway? See, gateway in a TCP/IP network, it's a device, right? That connects two different networks. Of course, you know this better. And it serves as a translator between the network protocols, right, friends? Good to go. Okay. Additionally, it allows data to flow between two networks with a different addressing scheme. Okay. Thereby ensuring that the packets are correctly routed and translated as necessary. That's it. So basically, it serves as a translator between two network protocols. Okay, this is the gateway. So that's it. Then typical example is a router that connects the local area network to internet. We can visualize that way. It's a LAN to the internet. Okay, this is about the gateway. Okay, now socket. You would have heard about socket, right? So it's basically an endpoint of a communication link between two programs running over a network. Socket means it's an endpoint communication. It consists of an IP address combined with a port number, creating a unique identifier for that specific communication session. Basically, it consists of an IP address with a port number. Okay, right. That's about the concept. You would have heard about the client server model, right? Yes. So in a client server model, the server will create a socket that waits for the client connection, and client will create a socket to initiate the communication within the server. That's it. It's like a, client server model, right? Deployed in client server model. That's a socket. Okay. So it provides an interface for programming the network communication. This is about the simple explanation on socket. Then another important one, DHCP. As you can see from the word DHCP, dynamic host or configuration protocol. So it's again a protocol used in TCP/IP to dynamically assign IP address. What is this dynamically? Let's see. See, it simplifies the network management by automatically providing devices within an IP address, subnet mask, default gateway, and other network parameters. You got it, friends? It simplifies the network management by automatically providing devices within a IP addresses, subnet mask within, sorry, not within, with an IP address. It provides devices an IP address, subnet mask, default gateway automatically. So no need of doing manually. So that's a beauty. Okay. So by doing that, it eliminates the need for the manual IP address configuration. So what it helps, it reduces the risk of address conflict, right? If you enter manually, there is always address conflict, right? Yes. So it allows for more flexible network management. That's a DHDP. Okay. Right. Then what is this MTU? MTU is nothing but the maximum transmission unit. It refers to the largest size of the data packet, largest size of the data packet that can be transmitted over a network link in a TCP/IP network. MTU, maximum transmission unit. It refers to the largest size of the data packet. Okay. So this MTU size includes the entire packet, including header, data, and it varies, depends on the network technology. Okay. So for example, if a packet exceeds the MTU size, then it must be fragmented into smaller packets. So yeah, that's the thing. Yes. So properly, if you configure the MTU, it can help to optimize the network and throughput. That's the bottom line. Right, friends? Good to go. Then now TTL. What is TTL? TTL is nothing but time to live. Time to live in an IP packet. So this is basically used to prevent packets from circulating indefinitely within a network. It will go on ringing, right? Yes. So it specified a definite period actually. So it prevents packet from circulating indefinitely. So it's an 8-bit field that specifies maximum number of hops that a packet can traverse. Okay. So each time the packet passes through a router, TTL value is decremented by 1. Okay. If the TTL reaches 0 before the packet reaches its destination, this is the point we need to note. If the TTL, time to live, reaches 0 because of this decrement by 1, before the packet reaches the destination, the packet is discarded. So it has to reach before that, right? So, and an ICMP time exceeded message is sent to the source. We have seen the ICMP, right? In the first, right? Yes, that's it. Right, friends? So this is all about TTE. Okay. So that's it. Of course, many more, but it looks like you guys are not very, keen on learning this, TCP IP suite. But let's see. There are many more. Let's see. If not no much of support, then probably I'll shift to another topic, other interesting topic. Okay, friends. Thank you. Take care. Bye bye.